How to find a molar ratio. This is the basis of stoichiometry. A molar ratio is the number of moles of an atom or a compound found from the coefficients of a balanced reaction. Below I have a reaction that's not balanced. It has N2 plus H2 yields NH3. So you can see that there's a different number of nitrogens on each side and a different number of hydrogens on each side. In order to use a molar ratio, you have to have a balanced reaction. So what I'm going to do is I'm going to place what's called a coefficient in front of the compound that I need to get the numbers to be balanced or equal on both sides. So I have two N's on the left. I'm going to put a 2 in front of ammonia to make that two N's, and that will be 6 H's. So then I'm going to put a 3 in front of the hydrogen gas so that I have 6 hydrogens on the left-hand side and on the right hand. This is known as a balanced reaction. You have an equal number of each atom on each side. Now, that number that I just placed in front of there, the coefficient, it represents the numbers of moles that you have of each of these substances in order to perform this chemical change. So 1 mole of nitrogen gas is needed with 3 moles of hydrogen gas, and you will make 2 moles of ammonia. Now, in order to solve equations, what you'll do is you'll make a ratio out of these coefficients. So say I have 6 moles of nitrogen gas and I want to know how much hydrogen gas I need. I start out with my given information and I make a fraction. I want to put the moles of nitrogen on the bottom so that it will cancel out. And I want to have moles of hydrogen on the top because that's what I'm going to. The numbers come from the balanced equation. So I have 3 for the hydrogen. So I'm going to put a 3 in front of my fraction. And then for nitrogen gas, I just have a 1. So that's going to go down at the bottom with the nitrogen moles. So what this shows me to do is that I multiply these two fractions, and it says that in order for this to be a complete reaction, I would need to have 18 moles of hydrogen gas. I can also do the same equation solving for the product, which is ammonia. So let's say that I want to produce 14 moles of ammonia, and I need to know how much nitrogen that's going to take. So what I do is I make my molar ratio by putting the moles of ammonia on the bottom, and I put the moles of nitrogen on the top, and then I get those numbers from my balanced equation. 1 mole of nitrogen gas is equal to 2 moles of ammonia. So what I'm going to do is I'm going to have 14 divided by 2, and that says that I need to have 7 moles of nitrogen gas to complete the reaction. So it is a 1 to 2 ratio. This ratio is our molar ratio. You can compare any substances that you want to. So if I were to redo the problem and say I needed to know how much hydrogen to have, I would just change what I'm solving for, and then I can use the molar ratio to compare those two substances. So let's say that I want to know hydrogen gas instead of nitrogen gas. So I need to change my coefficient to a 3. So this is a 3 to 2 ratio. For every 3 moles of hydrogen gas, I need 2 moles of ammonia to be produced. So 14 times 3 is 42, and I'm going to divide that by 2, so I get 21 moles of hydrogen gas. And that's how you use a molar ratio to start your stoichiometry problems.